today's lesson, we're going to learn about forces. In everyday terms, a force is a push or a pull. A better definition of this is a force is an interaction between a body or two and its environment, between a body and its environment. So we always speak about that a force is something that another body or the environment exerts upon something. When you have direct contact, you have what is called a contact force. Some examples of this would be the normal force. The normal force is exerted on any object by any surface with which it's in contact. Normal means perpendicular. Normal means perpendicular. And this force is exerted on the body. It is in a perpendicular direction, okay? No matter what the angle is. A frictional force is another one we must study. And a frictional force opposes the direction of movement, and it is exerted on a body parallel to the surface, where the normal force is perpendicular to the surface. We will indicate the normal force this way, and the frictional force as so. And as you can see by the arrows above, they are vector forces. There are also long-range forces that act on a body even when the bodies are even when it's not experiencing a push or a pull. Some examples may be magnets, the forces they exert on each other, or the gravitational force. And the gravitational force that exerted on a body from gravity is the weight. And this is mg. The normal force, once again, is the force perpendicular to an object exerted on it by a surface with which it is in contact. And finally, we want to know about the frictional force. These are some very common forces that we'll study. And that is going to, by definition, equals the normal force times mu, either K or S. And mu K is the coefficient of kinetic friction. Whereas mu S is the coefficient of static friction. Mu S is the coefficient and the difference being that the coefficient of kinetic friction occurs when an object is moving. And the coefficient of static friction is the friction of a body at rest. Superposition of forces. When you have several forces acting on a body, the overall force or the net force is going to be the sum of all the forces. So R, being the net force, is going to be equal to the summation of forces equals to F1 plus F2 plus F3 ... Okay, no study of forces would be complete without looking at Newton's 3 laws. The first one I like to call inertia, which says a body in an inertial state will remain in an inertial state unless acted upon by a net external force. And what does that mean? That means an inertial state is one of common velocity, or constant velocity, which could be at rest. Or at rest. Okay. And what is a net external force? A net external force means that if I'm pushing this way with a force of 5 newtons, and someone is pushing this way with a force of 5 newtons, and we want to know the R, the resultant force, we get 5 newtons minus 5 newtons equals 0. So we have to have a net force. However, if we change this to 6 newtons, we could see that R equals 5 newtons minus 6 newtons, and we have a net force of a negative newton. And what does it mean to be an external force? That means that if your car breaks down on the freeway, you cannot start it up by pushing on the dashboard. It must be external. It must be acting on the exterior of the object. Second law. Is the only mathematical one, and that's F equals ma. Force equals mass times acceleration. We have units of newtons, and we'll be using this a lot in our study, so you'll probably become very familiar with that. Finally, our third law is pairs. Forces come in pairs. How do I know that? I know that because if I stand on the floor, I'm exerting a force on the floor equal to my weight. The floor is exerting an equal and opposite force on me, and I know that because I'm not accelerating through the floor or accelerating upward. So forces come in pairs.